What are some of the security challenges that they are facing in their plants? What is it that they're seeing are the big security shifts that are taking place in the OT and IT environments? For us at Tenable, it's interesting because we deal with both the OT and IT part of the business. And so it'll be great hearing their views.
For us, we are primarily into identity security, and the conversations that we are having with manufacturing companies is all about how manufacturing companies are now contributing to the growth of GDP in India. And they are not just being pushed by the government, but I think there is a great opportunity for the manufacturing sector in India to really grow leaps and bounds. If you look at the moment you start saying, I want to scale up, I want to kind of really be faster than what I was doing for the last 20, 25 years. And if the government is opening up avenues to kind of augment growth, then it all boils down to how do I really scale up quickly and efficiently. And that all goes back to the fact that how do I use technology? How do I use cloud environment? How do I kind of use RPA, ML, AI? I mean, these are names and areas of interest for everybody. But I think the manufacturing in India has really been able to implement that very well. Is machine identity now becoming a new play for the hackers? So we all have talked about human identity. I mean, passwords and credentials have been a story for many, many years, and we have multiple kind of technologies and processes that we have been trying to manage these identities. With the piece which goes in automation, machine identities, which is a human, is kind of one part of it. But when an application talks to an application or an application talks to a robotic process, these are identities where authentication becomes a larger part, and all these are privileges which a machine is carrying. And if I'm able to attack and hack, then I am able to actually take over a very large part of the enterprise organization. It could be IT, it could be OT, and that could have a catastrophic effect which comes in. So our way of looking at it is conversations with CIOs and CISOs in this segment have been now going around saying, how do I take care of machine identity? How do I make sure that whatever is being put in for growth does not suddenly become a disaster for me? And that's where we have our conversations. And with that, I would like to invite Richard to dive a little deep into how we would be able to have conversations along with Tenable and CyberArk together. We bring to the table a much unique way of handling these threats in the new areas which have just come up.
Again, going in conjunction with some of the things that Rohan has stated, identity management is a very important part of this, because just accessing the engineering workstations gives you incredible power in terms of controlling very serious physical operations that can take place. And you definitely 100% want to ensure that only the right people have the necessary access to all of that incredible power that you have when you are operating an operational technology environment. To highlight kind of the differences and similarities between IT and OT. So specifically, IT, as everyone is called, is certainly aware, is always concerned with these three things from a security perspective: the confidentiality of the data, the integrity of the data, and the fact that the data is always available as and when needed. This is, I call it CIA, and it's been drilled into my head for the past 20 years. On the other hand, the KPI of an operational technology person, someone who's responsible to keep a plant producing something, or power, or machines, or whatever that plant happens to be, the primary KPIs are safety, uptime, and quality. Safety of life and limb, availability of the process as and when it needs to be available, and consistent quality of the product. And with respect to uptime, there's a very magic number that I have memorized now. It's 1440. And that is the number of minutes in a day. Because the KPI of an operational technology person is directly related to that very tightly. And they get penalized by the minute when availability is compromised. But it can be generally stated that anything that you do that's going to perform confidentiality and integrity and availability will concurrently help you to meet the KPIs in an operational technology environment, the KPIs of safety, uptime, and quality. Because even though it's a different language, they're both essentially doing the same thing. As a concrete example, if I have a mechanism that prevents somebody from making an inadvertent or illicit change to a programmable logic controller, that's going to help to maintain my uptime. It's going to help to maintain my safety. And those are security mechanisms that would help you to do that. Now, we'll talk a little bit about some trends. The first trend is the use or the kind of the integration of digital supply networks to help optimize manufacturing. I apologize for the dog. Always seems to happen. The typical thing that's been happening is we've been going from kind of a serial, isolated way of doing business in the manufacturing environment to a fully and tightly integrated way of performing business in a manufacturing environment, where we're focusing on what's called a smart factory, a factory that is tightly integrated with its suppliers, its logistics people, customers, planning department, and engineering. And what the implication of this is that more intelligence, more systems need to be placed inside of the smart factory in order to facilitate real-time data being pulled out of that factory, and in order to facilitate real-time data being injected into that factory. So the net result of this means that the isolation that we spoke of, I think Kartik actually mentioned this, the air gap that factories have enjoyed, production facilities have enjoyed, critical infrastructure has enjoyed, is very rapidly disintegrating as we strive to get more and more efficient in terms of our production capabilities and give our customers a better experience. The implication here is that additional intelligent devices and IoT devices and that sort of thing are being placed within the factory. I would say that this equipment is being placed adjacent to the machinery of production, not necessarily participating directly in the production process, but participating indirectly. And this is dramatically increasing the overall threat surface to which any facility would be exposed. So this is the trend. The common terminology for this is Industry 4.0. When this is a term that was coined by the pretty much all of Germany in the mid 2000s, and it's starting to rapidly accelerate. At this point in time, I believe something like 34% of production organizations are currently leveraging some of the concepts of Industry 4.0. But once you get there, it's really a tight integration between everybody. So just to make this point, it has a significant impact on the security of your OT organization. Some common myths that operators of critical infrastructure have had for a very, very long time. And the first one, we talked about air gaps. And my personal opinion, which I hold a very strong conviction to, is that air gaps are in reality a fantasy, right? You think you're not connected to the internet, but as soon as I take that laptop from my office and go into the plant and plug it into the plant, I'm connected. Even though I'm not directly connected to the internet, I have effectively connected to a machine that could have been contaminated to the internet by the internet. So that air gap doesn't really exist. In addition to that, very, very frequently, some manufacturers or some vendors of operational technology equipment will intentionally install maybe some VPN devices in order to allow them to access the systems remotely. We have an extreme example coming out of Florida last month, or in the month of February, late February, where the water treatment plant was compromised because the operators of that water treatment plant installed a copy of TeamViewer on an engineering workstation and then connected that to the internet. So the bottom line is, you may not think you're connected to the internet, but you are, like it or not, directly or indirectly. Another fallacy is because you're behind a firewall, you're safe. Everyone is called knows straight away that a firewall is only a partial protection. Many attacks can make it straight through a firewall, and firewalls can be misconfigured. So the fact that you think you've got your control systems behind a firewall that isolates you from your from the IT part of your organization, again, does not necessarily give you 100% protection against any kind of an attack. This next one is kind of interesting. Attackers don't understand control systems. Well, recently, I would say a very large majority of the cyber attacks against industrial organizations are motivated by money. And I'll give you an example that's taking place right now. A ransomware attack was launched against a Taiwanese manufacturer of PCs called Asus. I'm sure everyone in this room has heard of Asus, ASUS. And they're asking for $15 million in ransom in order to free up these machines and unlock them. So that is an attack against IT components, the IT components that are resident within the OT environment. That means, indeed, attackers don't necessarily have to understand control systems in order to launch such an attack and have a very disruptive impact on your production. Now, it gets scarier when you have, for example, a state-sponsored actor that does understand control systems, because that's when you get into a cyber physical attack, because that's when they go after the PLCs, perhaps at layer 0 of the Purdue model, and that's when they can wreak havoc and destroy machinery. Either one is very unpleasant, but the fact is, hackers don't necessarily need to be to completely understand control systems. They can pretty much stop at the engineering workstations and ruin your day. Our facility is not a target. Again, any facility can be a target because of financial motivations of the attackers. Okay, so you're not safe at the end of the day. Increasing risks, we have these recent attacks that have occurred. Locker Goga, that took down an aluminum plant about a year ago. 35,000 employees had to do business offline. I like to frequently cite the WannaCry attack that occurred against Maersk in 2018. That is one of the most severe attacks in history. Effectively, every single Windows machine on that environment was taken out. We also have some very arcane supply chain vulnerabilities that have been creeping in. One that we made note of last year was something called Ripple 20, where a company called Trek wrote a TCP IP stack, and that TCP IP stack was leveraged and licensed by many makers of intelligent devices. And that means that these Trek vulnerabilities are built into your devices, and you probably never even heard of Trek. And the big risk here is a lot of these devices are probably no longer supported by the vendors, which means that they can't be patched, and these vulnerabilities will continue to exist pretty much forever. Going to the top concerns of manufacturers on their OT assets, I'm going to just spend a very brief amount of time because we do a lot of customer interactions, and the list that's on this page here pretty succinctly summarizes the things that most of our customers are concerned with and the things that must be addressed in order to ensure a secure operational technology environment. Most of our customers, in fact, I haven't come up with a single one yet, that can give me an accurate list of all the assets that are present within his operational technology environment. So no one has an accurate asset inventory. You can try, but generally things deviate from the as-built configuration almost as soon as the guy who built the plant leaves the plant. Very few to none of our customers have visibility into the communication patterns. Within an operational technology environment, the systems should communicate in a highly orchestrated and very predictable way, which means that you can effectively baseline what normal communication is within the environment. Lack of visibility means that you can't establish a baseline and you can't detect anomalies because you're not monitoring for what's normal in the environment. If I don't know my asset inventory and I don't know my communication patterns, I cannot possibly understand my risk position from a vulnerability perspective. So again, we're concerned with lack of visibility due to exposure to vulnerabilities. A lot of the facilities I visited to date are effectively operating their plants as flat layer 2 networks without what I like to call horizontal segregation. So I've got an end-to-end plant and I don't have any mechanisms to block an attack that starts on the left side and goes to the right side. So effectively an attacker can make it all the way through the environment because I don't have adequate enforcement points in the environment. So this is kind of hinting towards a trend towards micro-segmentation within operational technology environments. I need to be able to detect indicators of compromise, network anomalies, and actual threats that may be present within my environment. And if I'm not looking, I'm never seeing these things. Because of an artifact of operational technology, and remember the KPI of an OT person is to keep the plant running. In a lot of cases, and this is not intended as a criticism, it's just that I'm an OT guy. My job is to make sure that plant stays up 7x24x365. I'm not going to take the risk of upgrading an operating system or applying a patch because the thing is working perfectly fine, and I don't want to take the risk that that patch is going to render my particular system inoperative. So again, lack of patching leads to systems that are vulnerable. And as we begin to migrate towards Industry 4.0, as the outside IT world begins its penetration into the OT world, this lack of patching turns out to be a serious problem for you. Now, one proof of value exercise I did here in Singapore, a manufacturing plant. 65% of the Windows assets in that environment were still running XP. And XP hasn't been supported the last time I checked since I believe 2014. So I'm 6 years out of patch? That's a lot. And lastly, most organizations have some kind of information security governance, especially for critical infrastructure that they must comply with. So these are the top concerns of most manufacturers on their OT assets. What Tenable does is 3 simple things. And I'll finish up with this slide and then we can get on to the next presentation. Number 1, our first job is to establish a baseline of all assets that are present within the organization. And in order to do it right, you need to be able to understand your IT assets and your OT assets. Meaning that if a system, if your solution is only looking at OT assets, in my opinion, you're missing about 80% of the risk. I'm going to repeat that. You're missing about 80% of the risk because almost every cyber attack against an operational technology environment begins with an assault against IT assets that are adjacent to or inside of that environment. So IT is the pathway to OT, and that's what's going to get you in trouble. So it's necessary to discover all of the IT and OT assets, the configurations of those assets, the state of those assets, and the vulnerabilities that exist on those assets. And when you get to that point, you effectively have what is a known state, a known baseline of your environment. Second thing is discover all the network protocols, the communication patterns that exist within the environment to identify what belongs and what doesn't belong. At that point, I now have 2 baselines. I've got one baseline of the equipment I've got another baseline of the network itself and the normal communication patterns and the protocols that belong on that network. Once I reconcile both of them, I can then at that point begin to monitor the environment for anomalies, indicators of compromise and intrusion. But I can't do an accurate job of monitoring until I know what my baseline asset count, my baseline set of assets is, and my baseline set of communication patterns is. Only then can I really begin the job of actually detecting anomalies and intrusions and help to ensure my environment. So it all begins with trying to understand these concerns, establishing a baseline, and then enforcing that baseline and alerting people when deviations occur from that baseline. So this is probably a 40,000 foot view of what the Tenable.ot solution